Hello guys, I hope you are doing good. Welcome to another video. Today we are going to solve another interesting JavaScript problem. This is a very common problem that you have heard, but there is lots of variation to this and we are going to see three different variations of the problem. The problem is we have to implement a throttling function. Throttling is a performance optimization technique where we want to restrict certain actions for certain count or certain time. So majorly what we see on the web through different mediums is the throttling that has been implemented is on the time basis only. So let's say if you are invoking a function, you can invoke that function at an interval of X amount of time, let's say 5 seconds or 10 seconds. But the throttling can be also implemented on the count. So on every fifth count or on every fifth time you have to invoke the function. So once in every fifth count. Now there is count based, there is time based. On to the time, there is another variation where we can have the leading and the trailing. So the leading says that the first invocation will happen immediately, and after that the second invocation and consecutive invocations will happen after the intervals. So the first one will happen immediately and after that the consecutive ones. The trailing says that the first invocation call will take place after the delay itself, so it won't be invoked immediately. So we are going to implement all these three types of throttling function. Let's start implementing this. Let me create a button over here. So button, that is click, and let me assign an ID to it, which is button. Now inside this I'm going to create the script. So document dot get element by ID. To this I'll pass the button and then I'll assign the click event. So on the click, we'll invoke the click event, and here let's create the onClick function. And let's run this. So if I say this, it should run. And if I'm clicking, you see that in the console log, we are seeing it is clicked and we are seeing the number of counts as well, how many times it has been clicked. So let's start implementing the throttle function. What throttle will do is it will throttle the click event so that we can check if the throttle is working properly or not. So first type of throttle which I'm going to implement is it will be the count based. So we have to create a throttle function that will accept a function and the a number as input, which will be the count, and it will invoke the accepted function once for the given count. So let's have that function throttle, and this will accept a function and the count. Because we have to keep track of how many times the function has been invoked, we have to create a closure. So here I'm just creating a closure with a variable, and I'm going to return another function from this. And here what we'll do is we'll just check if counter is not equal to count, then return. So as we have to invoke once only for the given count, right? We are starting from 0 and we are going till the count. So if it is not matching, we have to return the function. Otherwise, we'll reset the counter to 0 , and then We'll invoke the input function by setting the context and the arguments. So that's it. This is the simplest implementation of the throttle based on the count. Let's see if it is working or not. So we have the on click event. Let me create a throttle event of this. So throttle click, and here we'll use the throttle function. To this I'll pass the on click and let's say 4. So the function should be invoked once for every 4 clicks. So I have saved the file. Let's run this. I clicked once, twice, thrice, and now on the 4th time when I clicked, the function was invoked and we see the console log clicked. Again 1, 2, 3, 4. So on every 4th count it will invoke the function. So this is the first implementation of throttle on the count based. So this is the count based. Now let's implement the time based throttle. So I've commented this and let's create the function again. Throttle that will accept the function and the delay. So our previous function has accepted the count because it was on the count based, and this is a time based, so we are accepting delay over here. Now here the same thing, we have to create a closure, we have to return a function from here, and then because we have to target or track the time, right, when was the last function invoked, and then the second function should be invoked after the delay itself. So we are going to create closure with 2 variables. So I'm creating 2 variables, last function and last ran. So we can keep it undefined as well. There is no need to specify the values. It's perfectly fine. And then here I'm going to store the context so that when we invoke the input function, we can pass the context to that along with the arguments. Now this last run, this variable decides when was the function, this function was last ran. So if not last ran, so in the simplest implementation or the classic implementation of the throttle, it works as a leading. That means when we click, it will immediately invoke this function, and then the next invocation will happen after the delay. So that's why here I'm checking, adding a check if last ran. So if not last run, that means the function has not been invoked. This is the initial time. We are going to invoke the input function immediately with the context and the args. Otherwise, what we are going to do is we are going to clear the timeout. So to check the delay and run things after an interval, we have to either use timeout or the set interval or set timeout. So set interval keeps it running after each interval. The timeout, we have it under control, and with the timeout we can create recursion and recursively mimic the set interval as well. So here we are going to use the set timeout that because that gives us the better control. And so let me rename this. Let timer ID, because set timeout returns a timer ID. So we are going to return the timer ID if the function is invoked between the delay. So if the delay has not passed and if we are invoking the function, it should clear the timeout, and after that it should start a new timer. So here we are going to start the new timer, set timeout, and here we are going to add a check. Now this check is to determine when the last function was invoked and the function that we are invoking in the timeout, so the time has exceeded the delay or not. This is just a additional check that we have, a safety check. And if the delay has exceeded, we are just going to pass the context and the arguments, and we are going to update this variable last ran with the current time. So date dot now, and we are going to set it, and after that we are going to set the time. So when the function should invoke in the future, so that will be the current time minus when it was last ran. So I think that's it. That's the simplest implementation of the throttle function, the classic throttle function that you find it in the libraries. So let's see if it is working or not. So we have this throttle and we have this throttle click. Now here this will be time based. So let me increase the time to 1 second or 1000 millisecond. Let me save this. And now if I come over here, if I click, so the moment I click, it will print click, and the next click will, so it should happen after 1000-second delay, but it's not happening. Let's check what is wrong over here. So delay is there. The problem here was when in this if condition, right, we are checking if the last run was happened or not, and after that we are immediately invoking the function. But after that we are not updating this variable. So when we are making the consecutive calls, it's never going to the else part, and it keeps on invoking this line number 31 or the function input function directly. So what we have to do is we have to just update the last run with the current date and time, and this should work fine. Now if I come over here, let me update this time for 2 seconds so that it's visually visible that the click is happening after 2 seconds. So let's say if I'm clicking this button right continuously, you will see that the click is printed or logged only after the delay of 2 seconds. So this is the time-based throttling that happens. But the thing is, the first call, right, the first call happens immediately. So let's say if I clear this and if I reload, you'll see that the first call happens immediately and the second call will happen after the delay that we have provided. Now many times interviewer asked to update this function and have an option of trailing as well as leading. So leading will work same as what the current function is working as. So the initially when the button is clicked, the function will be invoked immediately and after the delay. In the trailing part, what happens is the first invocation of the function happens after the delay. So let's comment this throttle. This is the classic implementation. Let me add a comment over here. Classic works as leading, and now we are going to implement the third variation of throttle that will have the leading as well as the trailing option. So let's start creating that function throttle, and here we are going to take the function, the delay, and then the option. So option will have the leading, which is true, and trailing, which is also true by default. So in this case, even if both the values are true, right, this will work as a leading only, and only when the leading is false and trailing is true, it will pick the trailing changes. So again, we are going to have the timer ID and the arguments. So here we are going to store the arguments as well. This is required because we are dealing with the leading and the trailing cases. let's see the implementation. So return function, for each implementation we are creating a closure that returns a function and that will accept the arguments. Inside this closure function we are going to extract the option, so leading comma trailing from the option, and then here we are going to create a function, so that will be a delay function or a wait function. This will help us with all the consecutive calls similar to what we have here as the set timeout. We are wrapping the logic inside a function, the wait function, and here we are checking if it is trailing and the last args are available. So that in case of trailing only, the wait function will invoke, I mean the wait function, inside the wait function we are checking in case of trailing only, because the trailing will happen after the delay, and also all the consecutive calls after the leading will be considered as trailing only because they will happen after the delay. So that's why we are checking over here, and then I'm going to pass the context and the arguments and invoke the function, and then set the last arguments as null, and then we are going to use the timer id and we are going to run the set timeout, and we are recursively call this function with the delay. Otherwise we are going to set the timer id as null. So this is what wait function does in case of trailing, and if the arguments are present it will invoke the function. Here, because I have used the fat arrow function, I can directly access the context this of the parent, and if you are using the classic implementation, make sure you extract or store this in a variable and then use that variable inside over here. So now that our wait function is ready, we are going to add another check. So if not timer id, and this is the case of leading, so we have to immediately invoke the function. Otherwise we have to store the arguments for the next calls. So if it is not a leading call or it won't be invoked immediately, then we are going to invoke it after the delay. So that's why we are storing the arguments in a variable, in the closure variable in the parent, so that we can later use it. And then here we are going to say if the timer id is not present, which is the last timer id, then we are going to start a timer over here, and to this we are going to pass this wait function and the delay. So this is basically a recursive call, and here we are initiating it in case of the trailing. If it is leading, it will immediately invoke this function, and if it is trailing, it will invoke after the timeout, and we are using the helper function for this. And then this helper function will recursively, every time when it is called, it will start the timer. So I think that's it. We have the implementation. Now let's use this throttle, and here I'm going to set the options. So first thing we are going to do is we are going to set the leading as false and trailing as true. So how it should work is, when I click on this button, this should be clicked only after the delay of 2 seconds. So let's see if it is working or not. See, if I'm clicking, the click only happened after the delay of 2 seconds. That means it has started after the delay. So that's how trailing works. Now if I make the leading as true, you'll see that The moment I click, the function will be locked, and then the next call will be happen after the delay of 2 seconds. So let's say I click, it was locked, and then the subsequent calls are happening after the delay. So these are the three variations of throttle. Each of these is very important when you are working on applications where you see the multiple users are going to spam. For example, if you are working on a stock market application, right, where a user is continuously clicking on the button, or if you are on the IRCTC and user is continuously clicking on the button to reload or see the status, their throttle is a very helpful technique that we use to mitigate the load. So this mitigates the load on the client side itself, and the number of calls that we send or the number of actions we perform is restricted, and it is very useful technique in the performance optimization. I hope you have learned something new today. Thank you for your time.